So let's go ahead and take a look at our first example here. We have y equals 2x squared minus 8x plus 6. The very first thing that we really want to do is we want to identify all of the parts. We need to identify A, B, and C, and since that 2, that coefficient, the leading coefficient, is greater than 1, we know that it's going to be a little bit skinnier, and since it's positive, we also know that it's going to open up. So as we look at it, before we even start to graph this, we should have some sense of what it's going to look like before we even finish. Now, as I look at each step, I've got them labeled 1, 2, 3, and 4. We're going to take this step by step. And so the first thing that we're going to want to do is we're going to want to find the vertex. Remember, the vertex is a point that we need in XY form, and we're going to use our formula that was given to us, negative b over 2a. At this point, all we need to do is to evaluate this little function. We take the a, the b, the c. In this case, we only need the a and the b for the vertex, and we plug it into negative b over 2a, which gives us an x value of 2. Now, since the vertex represents a point or an ordered pair, we're going to need a corresponding y value for that. So we'll take the original quadratic function, y equals 2x squared minus 8x plus 6, and we'll take that 2 and we'll plug it in for each x value so that we can come up with the corresponding y value. In this case, that's negative 2. Now, since we've found the vertex, the very first thing that we're going to want to do on this graph is to come in here and actually plot the vertex. Now, fortunately for us, the axis of symmetry is the same thing as the x value of the vertex. Keep in mind, however, that this is an equation of a vertical line. X equals to any number is the equation of a vertical line. So the axis of symmetry is always going to be a vertical line. So what we're going to do here is this. We're going to take that vertical line, x equals to 2, and you can draw it with a little dotted line, or if you like, if you want to draw a little vertical highlighted line, anything to show you where the symmetry is going to be based off of. It is not actually part of the parabola or part of the graph, but this is a good guidance in order to actually graph the quadratic or graph the parabola. So we've got our two main parts. We've got our axis of symmetry and we have our vertex. Now we need to build the parabola around those two. So the first thing we're going to do is just go back to using a good old t-chart. And we'll supply some points for the t-chart. Now, which points do we want to supply? Well, from here, you would basically choose 2 points either to the left side of the axis of symmetry or to the right side of the axis of symmetry. And what this will do is this will give us the opportunity to graph 2 symmetrical points on the other side. So I'm going to choose x is 1 and x is 0. And we would plug this back into the original quadratic equation, quadratic formula function, which was y equals 2x squared minus 8x plus 6. And when we plug this in, 2x squared minus 8x plus 6, what we'll get is a 0 for this point and 6 for this point, and then we'll be able to plot those 2 points. Now, we have the vertex, we have 2 points on one side of the axis of symmetry, so simply now we just need to plot the points on the other side of the axis of symmetry, and now we have all the points necessary to graph the parabola. Now, keep in mind, graphing a parabola is not going to be like graphing a line where you can use a straight edge and make it nice and pretty. You're going to have to do the very best job that you can of drawing the U-shaped graph through these points. Remember, it is not a V, that's absolute value. This is a U for parabola. Now, it's not going to be perfect. You're just going to have to draw the best U that you can through those points. Keep in mind, for me to grade this accurately, you must show me the points. Every single one of these points is going to be necessary from a grading standpoint because of the fact that you will not be able to draw your parabola or your U-shaped graph perfectly. So this is the process of graphing a quadratic function in standard form. It is a process, it is a step-by-step process that you can use. You've got 1, 2, 3, and 4 steps that you can follow here. So what I would like you to do at this point is to go ahead and pause the video and use the previous example to help you graph sample problem number 1, and then if you would like, you can watch me work sample problem number 1 part A before you move on to sample problem 1 part B. But go ahead and stop the video at this point and graph either or both of these, and then watch the solutions after you finish that. Okay, so hopefully you were able to do that successfully. I'm going to walk you through these two and see how you did. Follow my process to make sure that you went through the same steps. The first thing I like to do is, even though I can see it in the quadratic function, I just like to go ahead and write it and identify the A, B, and C parts. That way when I'm plugging them into the formulas that I'm going to use, I can see them very quickly. So the very first thing that I'm going to do is to find the vertex in the axis of symmetry using x equals negative b over 2a. So b is 2, so I'll say negative 2 over 2 times a, which is negative 1, which is going to give me a negative 2 over negative 2, which gives me a positive 1. So x equals a positive 1. That is the axis of symmetry, and I'll use AOS as an abbreviation of the axis of symmetry. Now we need to use that 1 to find the vertex. So I'm going to plug in, now keep in mind, I'm plugging in 1 for the x value. The negative in this case comes in front of that, so that's going to be important for the value that you're going to receive out of there. So if you do your order of operations correctly, you should see that this is equal to negative 1, thus giving us a point of 1, negative 1 for our vertex. So the very first thing that I want to do is graph those two parts. So I'll represent the axis of symmetry with just a little highlighted vertical line. You can use a little dotted line if you like. Then I'm going to graph the vertex, 1 and negative 1. So there you have it. Now, my next job is to graph 2 points on either the left side of the axis of symmetry or the right side of the axis of symmetry. I'm going to do this using a T-chart. I'm going to choose the left side of the axis of symmetry, and the reason why is because I feel like 0 and negative 1 in this case are probably easier to calculate than 2 and 3, which are on the right side of the axis of symmetry. Now, I've run out of space to actually show you this work, but I think most of y'all should be feeling comfortable at this point in plugging in an x value into the equation and coming out with a corresponding y value. And in this case, we're going to get negative 2 with the 0, and we're going to get negative 5 with the negative 1. And so I'm going to plot these 2 points, 0, negative 2, and negative 1, negative 5. Now, just from where these points are leading me, I can start to see already very simply that this parabola is working its way down. And I should have recognized that right off the bat with the fact that the A value was actually -1. So that tells me that I have an upside down parabola, or it's going to be facing down. So this tells me that I've done my points correctly. If for some reason I got points that were going to lead me in an upward direction, I would be able to see very quickly that I've done something incorrect based off of what that A value is. So now I just need to plot the points that are symmetrical to this on the opposite side. So that's 1 unit away there. So I'm going to go 1 unit on this side. And this is 2 units away from the axis of symmetry, so I'll go 2 units on this side. And now I have plenty of points to graph my quadratic function. So I'll do the very best I can to create a U-shaped graph. It is important that we put arrows on the bottom of this parabola, because it does represent the fact that it will continue infinitely in either direction. And that is our fully graphed quadratic function representing y equals -x squared plus 2x minus 2. The parabola opens down. It is not skinny or wide. It is basically on its standard 1-to-1. So that is the first sample problem. Let's move into the second sample problem, where we can see that we run into something a little different with our A value. Now, in this case, I'm going to identify these parts again. The A value is 1/2, and it's a positive 1/2. Right off the bat, before I even get involved in this, I should know that this is going to be opening up, and the 1/2 value is going to make it open maybe a little wider than your normal parabola. Our B value is a -1, and our C value is also a -1. So I'm going to use my formula again. X equals -b over 2a to find my vertex and axis of symmetry. Keep in mind, since B is already negative, we have to do -1 over 2 times 1/2, which is going to give me 1 over 1. And again, my axis of symmetry is x equals to 1. Now keep in mind, this is just coincidence. It's not always going to be x equals to 1. I can go ahead and graph that, or give myself a little visual idea of the axis of symmetry, either with a little highlighter, or if you're using pencil, just a little dotted line, something to represent the axis of symmetry. Now I'm going to use this x value in order to, I'm going to use this x value to find the axis of symmetry by plugging it back into the original quadratic function. So then from here, I'll do my order of operations, and I come out with -3/2. So I have a vertex of 1 -3/2. Now, I know this isn't a pretty point, but really what it's doing is it's just giving us our minimum in this case. If you want to think of it as -1.5 instead, we're not going to write it that way. We're going to keep it in improper fraction form, but at least it gives you an idea of how to graph it. So if I'm going to go 1 and -1.5, that's going to put me right in the middle of the box as opposed to directly on a grid line. So now we've given ourselves an axis of symmetry, we've given ourselves a vertex. Now we need to give ourselves some points on either side of the axis of symmetry. In the previous example, I did 2 points. But in this particular case, I'm actually going to do a third point to give us a better view, since it's going to open up wider as opposed to being a standard looking parabola. I might need a little extra point to see that width, and in this case I'm going to use 0, -1, and -2 on the left side of the axis of symmetry, and when you go through the order of operations, that should give you the following points. So 0, -1, -1, 1/2, again that's going to bring us right in the middle of the block, and then -2 and a +3. Now that gives me the points I need on the left side. Now I just need to find the symmetrical points on the right side, and I have a clearer view of what that should look like. So if I graph that, you can see that that starts to peel out a little bit wider than your normal parabola would, and you get a better view of it. Now, as always, we have the calculator to kind of give us some guidance. So as I look at this, I can then go into my calculator to check myself. So I will check myself on part B here real quick, 1/2 x squared. So we're going to start off with 1 divided by 2, then x squared minus x minus 1, and I'm going to hit enter, and we can see that our particular graph looks fairly similar to the graph that we get on the calculator. So as always, the calculator is a good way to check to see if you're doing the graphing correctly. And keep in mind, we were using y equals. The calculator is going to be in function notation, so you can see f of 1 of x. So remember, f of x and y are representing the same thing when we're dealing with functions. So that is graphing quadratics in standard form. Probably the most involved form of graphing a quadratic, and as you'll see in later videos of graphing, other forms are a lot more straightforward and have a lot less steps.